You're sitting in an airplane at 35,000 feet. The flight is smooth, but for a moment, your mind wanders. What if something went wrong? What if the engines failed? What if the plane started going down? And then the obvious question hits you. Why isn't there a parachute under your seat? It seems like the most logical safety feature imaginable. Cars have airbags. Buildings have fire exits. Ships have lifeboats. So why don't commercial airliners have parachutes for passengers? The answer isn't about cost-cutting or negligence. It's about physics, human physiology, and the brutal reality of what happens at cruise altitude. Let me break down why this idea, despite sounding reasonable, would actually kill more people than it would save. First, let's frame the problem correctly. The question assumes that in an emergency, passengers could somehow exit the aircraft, deploy parachutes, and land safely. That assumption breaks down the moment you examine what's actually happening at 35,000 feet. A typical commercial flight cruises between 35,000 and 40,000 feet at speeds around 500 to 550 mph. Those two numbers alone, altitude and speed, make passenger parachuting physically impossible. Not difficult, impossible. And I'll explain exactly why. Let's start with altitude. At 35,000 feet, the outside air temperature is roughly -50 to -60 degrees Celsius. That's cold enough to cause frostbite on exposed skin in under a minute. But temperature is the least of your problems. At that altitude, air pressure is about 1/4 of what it is at sea level. Your body needs oxygen to survive, and at 35,000 feet, there simply isn't enough. Without supplemental oxygen, you have roughly 15 to 30 seconds of useful consciousness. After that, you lose motor function, decision-making ability, and eventually consciousness. Now imagine trying to put on a parachute, open an emergency exit, and jump, all within that 30-second window. It's not happening. Military pilots who eject at high altitude use specialized equipment, oxygen masks, pressurized suits, automatic deployment systems. Even with all that, high-altitude ejections are extremely dangerous. Commercial passengers would have none of that equipment. They'd have a parachute and nothing else. They'd be dead before they reach 20,000 feet. Now let's talk about speed. A commercial airliner at cruise speed is moving at roughly 500 mph. That's about 800 kilometers per hour. If you tried to jump out of an aircraft moving at that speed, the airflow would hit you with the force of a high-speed car crash. Humans have jumped from aircraft at lower speeds, but those are military paratroopers exiting from slow-moving cargo planes at 120 to 150 mph. Not commercial jets at 500 mph. The aerodynamic forces at cruise speed would cause severe injury or death the instant you left the aircraft. Your body would tumble violently. You could be knocked unconscious. Even if you survived the exit, you'd be in no condition to deploy a parachute. But let's assume, hypothetically, that somehow the aircraft slowed down and descended to a lower altitude. Let's say 10,000 feet and 200 mph. That's still faster and higher than most parachute jumps, but let's say it's survivable. Now you face a different problem: time. In a real emergency, how much time do you have? If there's a structural failure, maybe seconds. If there's a fire, maybe minutes. If all engines fail, maybe 10 to 15 minutes of glide time. But here's the critical issue. You're not the only person on the plane. There are 150 to 300 other passengers. All of them need to put on parachutes, get to an exit, and jump, one at a time, through a door that's maybe 6 feet tall and 3 feet wide. Do the math. Even if each person took only 10 seconds to jump, which is wildly optimistic, evacuating 200 passengers would take over 30 minutes. The plane doesn't have 30 minutes, it has maybe 10. That means most passengers wouldn't even get the chance to jump before impact. Now let's address the most common misconception. Most people think airplane emergencies involve the plane slowly descending, giving everyone time to react. That's not how it works. The vast majority of aviation accidents happen during takeoff or landing, when the aircraft is low and slow. At those altitudes, parachutes are useless. You need at least 1,500 to 2,000 feet of altitude to safely deploy a parachute and land. If the plane is at 500 feet and descending, there's no time. And if the emergency happens at cruise altitude, you have the oxygen and speed problems I just described. The window where parachutes would actually be useful is incredibly narrow. And even in that narrow window, the logistics make it unworkable. Let's break down what would actually need to happen for passenger parachutes to work. First, every passenger would need training. Real training, not a safety card, not a video. Not actual hands-on parachute training, including how to exit an aircraft, how to deploy the chute, how to control descent, and how to land without breaking your legs. Experienced skydivers train for months before jumping solo, expecting untrained passengers, many of whom would be panicking, to successfully use a parachute in an emergency is unrealistic. Children, elderly passengers, people with disabilities, they wouldn't be able to do it. You'd have chaos, not an orderly evacuation. Second, the aircraft would need to be redesigned. You'd need larger exits, or more exits, to allow faster evacuation. But larger exits weaken the fuselage. They create structural vulnerabilities. They add weight, and weight is everything in aviation. A parachute weighs around 10 to 15 kilograms. Multiply that by 200 passengers, and you've added 2,000 to 3,000 kilograms to the aircraft. That's weight that could have been fuel, cargo, or additional passengers. It directly impacts range, efficiency, and operating costs. Airlines would have to charge significantly more per ticket to offset that weight penalty. Third, you'd need a way to depressurize the cabin and open exits at altitude without killing everyone in the process. Rapid decompression is violent. It can cause injuries. It would terrify passengers. And once the cabin is depressurized, everyone is on a clock. Oxygen masks buy you maybe 12 to 15 minutes. That's not enough time to evacuate hundreds of people through parachutes. Here's the real-world application of parachutes in aviation. They exist, but only in very specific contexts. Some small private aircraft, particularly single-engine planes, are equipped with whole aircraft parachute systems. These aren't individual parachutes. They're a single large parachute that deploys from the aircraft itself, lowering the entire plane to the ground. It's designed for situations where the pilot loses control or the engine fails. But these systems only work on small, light aircraft. A Boeing 737 or Airbus A320 weighs 40 to 80 tons. There's no parachute system in the world that can safely lower that much mass. The forces involved would rip the parachute apart. Military cargo aircraft sometimes have parachute-trained personnel on board, but those are trained soldiers or airborne troops, not civilians. They jump from aircraft specifically designed for that purpose, with rear ramps or side doors, at controlled speeds and altitudes. It's a planned operation, not an emergency evacuation. Now let's talk about the edge case. What if, hypothetically, you had unlimited time, perfect conditions, and a fully trained passenger manifest? Could it work then? Maybe. But that scenario never happens. Real emergencies are chaotic, fast-moving, and unpredictable. Systems that rely on perfect conditions don't work in aviation. Aviation safety is built on redundancy, simplicity, and systems that work even when everything else is going wrong. Parachutes for passengers fail that test. Here's the conclusion. Airplanes don't have parachutes because the scenarios where they'd actually be useful are vanishingly rare, and the scenarios where they'd be useless or actively harmful are overwhelmingly common. Aviation safety isn't about giving passengers a way to escape a failing aircraft. It's about making sure the aircraft doesn't fail in the first place. And the statistics prove it works. Commercial aviation is the safest form of transportation ever created. You're more likely to die driving to the airport than flying across the ocean. In the United States, the fatal accident rate for commercial airlines is roughly 1 in 10 million flights. When you compare that to the complexity, cost, weight, and limited usefulness of passenger parachutes, the decision becomes obvious. The parachute isn't there because it doesn't solve the problem. The aircraft's engineering, the pilot's training, and the layers of redundant safety systems, those solve the problem. So the next time you're on a flight and you wonder why there's no parachute under your seat, remember this. You're sitting inside one of the most over-engineered, obsessively tested, and statistically safest machines ever built. The parachute isn't missing because someone forgot. It's missing because it's unnecessary. And that's exactly how it should be. Now, if you've ever wondered what actually happens if all the engines fail on a commercial jet, I've made a separate video breaking that down in detail. But there's one more layer to this that's worth examining: the psychological factor. Imagine you're a passenger on a flight, and the airline tells you there are parachutes on board for emergencies. What does that do to your perception of safety? For most people, it would increase anxiety, not reduce it. The presence of parachutes implies that escape might be necessary. It suggests that the aircraft itself isn't safe enough. That's the opposite of what airlines want to communicate, and it's the opposite of reality. Modern commercial aircraft are designed with multiple redundant systems. Engines can fail, and the plane can still fly. Hydraulic systems can fail, and backups take over. Electrical systems have redundancies. Even if both pilots were incapacitated, modern autopilot systems can land the aircraft. The entire design philosophy is built around the idea that no single failure should lead to catastrophic loss. Parachutes don't fit into that philosophy because they represent a single point of failure, human error, which is far more likely to cause harm than the mechanical systems they're meant to bypass. There's also a legal and liability issue. If airlines provided parachutes, they'd be implicitly accepting responsibility for ensuring passengers could use them. That would require training, certification, and legal frameworks that don't currently exist. If a passenger failed to deploy their parachute correctly and died, the airline could be held liable. If a passenger panicked and refused to jump, causing delays that led to other deaths, who's responsible? The legal complexity alone makes the idea unworkable. Finally, let's consider the actual survival rate of parachute jumps, even under controlled conditions. Experienced skydivers have injury rates of around 0.2 to 0.3% per jump. That's with training, proper equipment, and ideal conditions. Untrained passengers jumping in an emergency at non-ideal altitudes and speeds would have far higher injury and fatality rates. You'd essentially be trading one low-probability risk, aircraft failure, for another high-probability risk, parachute failure or misuse. That's not a safety improvement, that's a safety downgrade. So when you see that your seat cushion can be used as a flotation device, understand what that actually represents. It's not because water landings are common, they're extremely rare. It's because in the specific scenario where a water landing occurs, a flotation device is lightweight, simple, requires no training, and genuinely improves survival odds. It fits the criteria for effective aviation safety equipment. Parachutes don't, and that's why they're not there.